So this is part 2 for our section 11.3 lesson on the ellipse. And so let's get into some of the homework problems that you'll be looking at in this section. So for problems 43 through 54, you're supposed to come up with the center of the ellipse, the focal points, and the vertices, and then you're going to sketch the graph. So just a reminder, there's graph paper on Moodle up in the general section. If you want to print some off there, it's a printable version, either the large or the small, whichever one you prefer. I'm just going to do a little rough sketch, is what we did in class when we went through these. So first of all, to find the center, just think about what you did when you found the center of a circle. An ellipse is just another version of a circle. It's just that it's not the same distance all the way around from the center. But we find the center of the ellipse the same way as we did with the circle. So the center will be x-coordinate 3 and y-coordinate -1. Okay, for focal points, we're going to use our formula that we use a lot with ellipses. C squared equals a squared minus b squared. And when we find C, we'll know how far it is from the center to each of the focal points. So C squared is going to be a squared, which is 9, minus b squared, which is 4. So C squared is 5. So C is going to be the square root of 5, and for all of these radicals, you can just round them to the nearest tenth. So the square root of 5 is 2.2. plus minus. So what that tells us is that from the center, we would go, because this ellipse is taller than it is wide, notice how a squared is underneath the y variable, so this is going to be the tall ellipse. As a matter of fact, we can just go ahead and I'll just do a little rough sketch here. You'll need to put your homework answers on graph paper, but this is how you do it. So find the center, 3, -1. And then all the other points like vertices, co-vertices, focal points, they're all based on, they start at the center. Okay, so to get to the focal points, I'm going to go up 2 and just a little bit more. Since this, again, this is the tall ellipse, the focal points are going to be on the major axis, which is vertical. So up 2 and then just a little bit more, just a shade above +1 on the y. And then from here, I'm going to go down 2 and just a little bit more, just a little bit below -3. So mine's not exactly to scale, as you can see, but that's the idea. Up 2.2 and down 2.2 to get to the focal points. For the vertices, I'm going to go up 3 and down 3. Remember, A represents the distance from the center to the vertex or vertices. And since a squared is 9, that makes A is 3. So just count up 3. And that point represents one vertex, and then down 3, that point would represent the other one. And then for co-vertices, that's what B tells us. We do, this is B squared, so the square root of 4 is 2. So co-vertices would go in the other direction. If the primary axis, the major axis, is vertical, then the minor axis is going to be horizontal. So I go 2 places to the right and 2 places to the left. And these outside points are going to get connected, and that's going to represent the graph. And these inside points vertically lined up with the center represent the focal points. So let's go ahead and do actual ordered pairs for the focal points. We know how far it is, so just think of it this way. If you went up and down to get to the focal points from the center, it's like you started at the center and you went up 2.2. So just think about adding 2.2 to negative 1. And you got 1.2. So this top focal point is the point 3, 1.2. And then to get to this one, you started here and you went down. So that's like subtracting 2.2. So what I'm showing you here is how you can always get the focal points and the vertices if you are traveling up and down. Just add and subtract to the y coordinate. So this would be the other focal point down here would be 3, negative 3.2. So those are the focal points. So we found those, the vertices. Here we're going to start at, again, everything starts at the center, so 3, negative 1. So to get to this top vertex, we added 3. Okay, so instead of adding the C number to get to the focal point, that's what we did for the focal points, we add 3. So one of the vertices, I'll just put my vertices over here, negative 1 plus 3 would be 2, so that's the point 3.2 right there. And then this one would be, you start at negative 1 and go down 3, should be at negative 4. Those are my vertices. And they didn't say about anything about identifying what the co-vertices are, so you don't have to worry about making that part of your answer. And so it looks like we're finished. We found the center, the focal points, and the vertices, and then we sketched the graph. Okay, so that's a good example of one of your homework problems in this section. Here's another one that's not in standard form. So remember, to get it in standard form, we're going to divide everything by, in this case, 16. And so the standard form of this ellipse would look like this. Y minus 4 squared over 4. 4 over 16 is 1 over 4. And that equals 1. So you got to make it equal to 1 to get it in the standard form. All right, and so the center, again, the x-coordinate will be negative 5. Y-coordinate will be positive 4. For the focal points, we need to find out how far away it is from the center to each of the focal points. And for this problem, it's going to be a wide ellipse. Notice that x squared has a squared, which is bigger, so it's the major axis is going to be horizontal. Okay, first let's find out what the C number is. So we do C squared is a squared minus b squared. So a squared is 16, b squared is 4, c squared is 12. So we do the square root of 12 rounded, and that's about 3.5. Okay, so remember, for the wide ellipse, now we're going to start at the center. We can just go ahead and do our little rough sketch. So start at the center. Here's negative 5, positive 4. But this time, unlike the previous problem where the ellipse was tall, we moved vertically to get to the focal points and the vertices. Now we're going to be moving horizontally for the wide. So I'm going to go right 3.5, which is about right there, and left 3.5, which is about right there. And these are going to be focal points. Now the actual points, now we're going to be operating on the x-coordinate. So just think, add 3.5 to x and subtract 3.5 from x. Okay, so it's going to be negative 1.5 for this one, negative 1.5, 4. So we'll just list them out here, I guess. And the other one, if you are at negative 5 and you go left 3.5 more, that's negative 8.5, 4. All right, now the vertices. A squared is 16, so that means A is 4. So for the vertices, we're going to go back to the center and we're going to go right 4, which we change color. That would be right there. And left 4 would be right there. Okay, so the ordered pair of the vertices, again, if you can't see it from the graph, if all you were doing is having to come up with it without graphing, you're basically just going to add 4 to go to the right. That makes -1, 4, and subtract 4. That makes -9, 4. And we don't have to list the vertices, but we need to know what they are so we can sketch the graph. So we're going to travel b units. So b squared is 4. So that means b is 2. So we're going to go 2 up and 2 down for the co-vertices. And then those 4 points on the outside are going to be connected. And that is your rough sketch of this particular ellipse and all the information that we were asked to come up with. Okay, make sure I got it all. So we found the center, the foci, the vertices, and we sketched the graph. All right, moving on to this problem. The problem here is this isn't in standard form, and we're going to have to complete the square on both x and y. So let's do an example of that. So first, if you do have a constant like we do here, we need to move any constants, numbers without variables, over to the right side. And now we're going to do completing the square on both x and y. Really no problem for x because the lead coefficient is just 1, so that's going to be x plus 2 quantity squared. A little bit different here because we can't complete the square unless this lead coefficient is 1. So I'm going to pull out 4. Okay, and now I'm going to complete the square on y. So all I did was factor out 4 to make this coefficient become 1. Notice it still equals. If I distribute 4, I get what's above. And now I'm able to complete the square on y. So that's going to be y minus 1 quantity squared. And now I'm going to balance out the equation. So I need to add 4 because of this, 2 squared. So I started at -4. I'm going to add 4, 2 squared. Maybe I'll just do it like this. Okay, I'm going to add, because I added it to the left side. Now I'm going to add it to the right. And then I'm going to add -1 squared times 4. Okay, so literally, I'm showing it a little bit differently so you can see where these numbers come from. -1 squared times 4. Okay, and then simplifying, this right side is going to be -4 plus 4, which is 0. And then this is going to be +1 times 4. Okay, and then remember, standard form ellipse equations need to equal 1, so we're just going to divide everything by 4. And that's just over 1, of course. Okay, so I think I'll go to a new slide where I've got more room, and then we'll answer all the questions that pertain to this. But I just wanted you to see where the equation came from. So we got x plus 2 squared over 4 plus y minus 1 squared equals 1. Okay, x plus 2 squared over 4 plus y minus 1 squared equals 1. Okay, So center is going to be negative 2, 1. For the focal points, we need to find out what c is. Remember, c squared is a squared minus b squared. So c squared is going to be 4 minus 1. C squared is 3, so c is plus minus the square root of 3, which is about 1.3, I believe. 1.7. All right. So this particular ellipse is wide. The a squared is bigger, obviously, than b squared, and it's underneath x. So we've got a wide ellipse. And so we're going to go left and right 1.7 to get to the focal point. So really at this point, I'll probably just leave the graphing up to you. I think you can probably get the graph, but I'll show you what all of the points are. So for the focal points, since we're moving left and right, our major axis is horizontal, in other words, just do negative 2 plus 1.7, and that'll give you the right focal point. That's negative 0.31, and then go left, and that should be negative 3.71. Okay, and then for the vertices, we need to know what a is. Well, a squared is 4, so a is 2. So once again, starting at the center, going right 2, we would be at the point 0, 1, and going left 2, we'd be at the point negative 4, 1. We need the covertices because of graphing. So for covertices, we need to know what b is. Well, b squared is 1, so b is 1. Square root of 1 is 1. So for the covertices, we're going to travel up and down. So just think about being at the center and going up 1. That would be negative 2, 2. And if you went down 1, that would be negative 2, 0. So you'll plot the vertices and covertices and then draw your ellipse around those and then place your focal points on the horizontal major axis, and that will complete your graph. Okay, so our next example, another one where we have to complete the square. So I'm going to move the constant over to the right side, and this time I'm going to put the x terms together just to make it a little bit easier when it comes time to complete the square on x, and then do the same thing with the y terms. So just do a little rearranging, and then I'm going to move negative 11 over to the right as positive 11. So to complete the square, once again, I need to factor out 9, make this first coefficient 1. That's x squared minus 2x. And then factor out 4. That's y squared plus 4y. And now we're going to just double check at this point. It's always a good idea to make sure if you distribute 9 to both terms, you should get this. If you distribute 4 to both terms, you should get what's above it. And now we're ready to complete the square on both x and y. So to balance out the equation, I'm going to take negative 1 squared, which is 1, times 9. So I'm going to add 9 for completing the square on x. And then 2 squared is 4. 4 times 4 is 16. And that balances out completing the square on y. And when I add these up, I get 36. And now I'm going to divide by 36 to get this into standard form. So this becomes x minus 1 quantity squared over 4. This is y plus 2 squared over 9 equals 1. So the center, again, is going to be 1, negative 2. And the problem really works out a lot like our previous problems. Let me go to a new slide where I've got a little bit more room. So we've got x minus 1 squared over 4. And y plus 2 squared over 9 equals 1. So we've already said the center. And eventually, again, you'll sketch the graph, but I'm going to give you all the points that you can plot. So to get the focal points, we need to know what c is. C squared is a squared minus b squared. So c squared is going to be 9 minus 4. So once again, c is going to be the square root of 5, and that's about plus minus 2.2. So the major axis is going to be vertical. It's going to be a tall ellipse. So this time, to get to the focal points, we're going to add and subtract. We're going to add 2, subtract from the y coordinate. So to get to the focal point up at the above, you would add 2.2 to the y, and then for the one below, you would subtract 2.2. All right, so the focal points will be 1.2, x is 1, y is 0.2, and then the other one would be at 1, negative 4.2. For the vertices, we need to find out what a is, and a squared is 9, so a is 3. So we'll do the similar procedure. It's just that instead of adding c, this time we're going to add a and subtract a. So for the vertices, we'll do 1, and then negative 2 plus 3 is 1. And negative 2 minus 3 is negative 5. And once again, for the co-vertices, we need those to sketch the graph. So b is going to be 2. And we go this time for the co-vertices, so for co-vertices, we'll go left and right 2 places. So if I go to the right, that's like adding 2 to 1. That gives me at 3, negative 2. And going to the left, that's subtracting 2 from 1. It's negative 1, negative 2. So again, plot these points and connect the vertices and co-vertices, and the foci should be inside the ellipse, and you'll have the graph. And that's pretty much what we got accomplished. The rest of these, here's some other examples, but we stop there. So the assignment, we're going to pick this up. We're going to do this as part 2 of our lesson. So, actually, this is part 2. Sorry, let me back up. So let me go ahead. We skipped over this one, and let me go ahead and work through this problem. This is just more of the problem before this is just more of the same. So for this problem, we're supposed to find an equation for the ellipse. So the center is at 2, negative 2, so we can go ahead and set that part up. The x-coordinate is 2 for the center, so we're going to do x minus 2 quantity squared. Just think about circles again. And the y-coordinate is negative 2, so that's going to make y plus 2 quantity squared. Got to equal 1. All right. So let's see, a squared is the distance from the center, or a is the distance from the center to a vertex, okay? And it's 5 units, apparently, from the center to the vertex, so a is 5. And let's see if we can tell if this is a vertical or a horizontal major axis. So if you have to, you can make a little sketch. You got to graph it anyway. So if you want to just go ahead and plot all these points on your graph paper first, but just to kind of give you an idea, here's 2, negative 2. And then that's the center. And then we have a vertex at 7, negative 2. So that's over here. So that tells us that our major axis is horizontal, which tells us that a squared has to go under x. So a is 5, a squared is 25. All right. The focal point is at 4, -2. So that would put it right there, which tells me that C is 2. C is the distance from the center to a focus. So since C is 2, C squared is 4, and we can use that information to help us determine what B squared is. So C squared equals A squared minus B squared. So -21 is negative B squared. So positive 21 is positive B squared, and now we just do the square root of 21 and round it, and that's about 4.6 when we actually plot. Now you're going to actually put B squared here, but when you plot, you'll do the square root, which is about 4.5. So you go up about 4.5, down about 4.5, and that'll be your co-vertices. Okay, so your co-vertices will be going this way, vertices out this way. Yeah, it's a really rough sketch, but you should be showing a horizontal major axis. So there's the equation, and then sketch the graph from there. All right, let's try this one. And once again, the length of the major axis is 8, but we don't know until we analyze this, is the major axis vertical or horizontal? Well, it's really all about the positioning of the focal points, because if you just do, again, a little rough sketch, we have a focal point at 5, 1, and another one at -1, 1. Okay, and focal points are always on the major axis. So that means that we have a horizontal major axis, which means a squared should go underneath x squared. All right. Another thing we know is we can determine what the center is. It should be right in between these 2 points. So you can do the average of the x coordinates if you have to. You could do 5 plus -1 divided by 2. So that means the center is going to be 4, 1. Oops, 2, 1. It's 4 divided by 2. Okay, there's the center. So let's do our equation. X, so here's the point 2, 1. So it'll be x minus 2 quantity squared plus y minus 1 quantity squared. And let's see what else that we know. Well, if the length of the major axis is 8, that means from the center, it's got to be 4 units on either side. So 1, 2, 3, 4, right there. Again, this is more or less for graphing purposes. So that means A is 4. So A squared, obviously, then is 16. And since the x-axis, the major axis, is horizontal, that means x gets the bigger denominator. It gets A squared. And now let's find out what B squared is. C squared is A squared minus B squared. So C squared has to be, again, the focal points are 1, 2, 3 units away. The focal points are these blue dots. We plotted those at the beginning. So C is 3, so C squared is 9, A squared is 16, and we're going to find B squared. So -7 is negative B squared, so 7 is positive B squared. So there's the equation. And you would do the square root of 7, which we can give you that. Square root of 7 is about 2.6, so you go up 2.6 and then down 2.6 and connect those, and that will be your graph. But this is the equation that you were asked to find. All right, I think we got one more. Let's see, we have the center at 1, 2. Okay, so we can go ahead and do this part of our equation. The x-coordinate of the center is 1, and the y-coordinate is 2. All right, and let's see. The focus is at 4, 2, and the ellipse contains the point 1, 3. Okay, so let's see what this means. Just a little rough sketch. So there's 1, 2. And the focus being at 4, 2, again tells me that we have a horizontal major axis. We know C is 3. All right, so I'm just writing down what we know. So there's a focal point. Here's another focal point. And we know that the point 1, 3 is included on this graph. Okay, so apparently if 1, 2 is the center and we have a horizontal major axis, we know that because the focal points are on this horizontal line, then this must represent the co-vertices, or one of the co-vertices. So B must be 1. It's 1 unit from the center to this point right here, and it must be a co-vertex. So we can use this information to help us find a squared. So c squared is a squared minus b squared. So looks like a squared is 10. And once again, we'll put a squared underneath x, x being horizontal major axis. And b squared is 1. You don't really need denominator 1. But this would help you with the graph. So those are your co-vertices. And then you just need the square root of 10, which is a little bit more than 3, just beyond the focal points. These would be your co-vertices. And so your rough sketch graph is going to look like this. And that's it. That takes care of it. And so that's what we were doing for this assignment. And hopefully those examples will help you out. If you have any questions, let me know.